The James Webb Space Telescope has provided us with one of the most detailed looks yet at Proxima Centauri and its most talked-about planet, Proxima B. Located just over 4 light-years away, Proxima B sits in what scientists call the habitable zone, a region around a star where conditions might allow liquid water to exist. This makes it one of the most intriguing exoplanets discovered so far and a potential candidate in the search for life beyond our solar system. Proxima B orbits Proxima Centauri, a small red dwarf star and our closest stellar neighbor. The planet is accompanied by at least one confirmed companion, Proxima C, and there are hints of a third, possibly smaller planet, Proxima D, which might be about the size of Mercury or Mars. Despite its potential, Proxima B is no Earth twin. It completes a full orbit in just 11.2 Earth days and stays very close to its parent star. This proximity likely means it's tidally locked. One side always faces the star in endless daylight, while the other remains in permanent night. That extreme contrast in lighting and temperature could affect everything from weather patterns to the possibility of habitability. Proxima Centauri itself is part of the Alpha Centauri system, a trio of stars that includes the more prominent Alpha Centauri, A and B. These two are visible to the naked eye, but Proxima Centauri, a faint red dwarf, requires a telescope to see. Though it's the smallest of the three, it's the one closest to Earth. Red dwarf stars like Proxima Centauri burn slowly and can live for trillions of years. But they also tend to flare, releasing powerful bursts of radiation. These stellar eruptions can strip away a planet's atmosphere, an essential layer for maintaining stable temperatures and shielding any surface life from harmful radiation. Because Proxima B is so close to its star, it may receive intense ultraviolet and X-ray radiation, which could make it far less hospitable than its location in the habitable zone suggests. Still, the discovery remains exciting. The James Webb Space Telescope, designed to capture infrared light from distant objects, is well equipped to search for atmospheric clues. By studying the light that Proxima B reflects or emits, scientists hope to detect signs of water vapor, carbon dioxide, or other gases that could point to an atmosphere. Even if we do find an atmosphere, it doesn't guarantee that Proxima B supports life. Take Venus, for example. It has a thick atmosphere, but it's scorching hot and filled with toxic gases. Proxima B could face similar challenges. What makes Proxima B especially interesting is its classification as a super-Earth, a planet larger than Earth but smaller than Neptune. That size increases the chances it has a rocky surface and maybe even plate tectonics or volcanic activity. And given how close it is to us, it remains one of the most accessible targets for future exploration. However, getting there is another story. With current spacecraft technology, like Voyager 2, it would take over 75,000 years to reach Proxima B. That's why scientists are investigating faster methods, such as solar sail propulsion. These ultra-thin reflective sheets could ride on light from the sun, pushing small probes to nearby star systems in a fraction of the time. Meanwhile, the search for exoplanets continues at full pace. Thousands have already been discovered. Some are gas giants hugging their stars, others are icy and isolated. Some are similar in size to Earth, like Proxima B. Astronomers use several methods to find them, most commonly, the transit method, which detects tiny dips in a star's brightness when a planet crosses in front. Other techniques include tracking a star's wobble or even capturing direct images of large planets orbiting far from their stars. Another exciting area of research is exomoons, moons orbiting planets beyond our solar system. These could also host life, depending on their environment. The TRAPPIST-1 system, for example, has 7 rocky planets. Thanks to the powerful capabilities of the James Webb Space Telescope, we have already achieved a groundbreaking milestone in exoplanet science, the detection of carbon dioxide in the atmosphere of a planet beyond our solar system. This discovery is more than just a chemical fingerprint, it's a window into the processes that shape alien worlds. It provides clues about planetary formation, surface conditions, and the possible presence of atmospheres capable of supporting life. JWST doesn't just observe planets, it also peers into the birthplaces of planetary systems, swirling disks of gas and dust that surround young stars. By analyzing these dusty nurseries, the telescope is helping scientists uncover the ingredients that go into building planets and possibly even life itself. It examines the chemistry of water ice, organic molecules, and gases, painting a detailed picture of how worlds evolve in the cold darkness of space. In this broader context, Proxima B emerges as one of the most compelling subjects in the search for extraterrestrial life. Though it orbits a volatile red dwarf star and may face atmospheric instability, its location, just over 4 light-years from Earth, and its rocky, Earth-like size make it a prime candidate for further study. Its very existence challenges long-held assumptions about what kinds of planets can be habitable and how close they might be to us. The idea that the nearest potentially life-supporting world may be within reach, astronomically speaking, has ignited the imaginations of scientists and dreamers alike. Still, Proxima B is far from a confirmed haven for life. We don't yet know if it has an atmosphere, or if it does, whether that atmosphere is stable and protective. The intense radiation from its host star could have stripped away its outer layers long ago, leaving a barren, lifeless surface. But even so, every new observation, every faint spectral line, every dip in starlight, adds a piece to the puzzle. Whether Proxima B is a dead world or a dynamic planet with oceans and clouds, it teaches us something invaluable about the diversity of planets in our galaxy. For now, Proxima B remains a nearby mystery, a cosmic neighbor cloaked in shadow. It pushes the boundaries of our understanding and fuels one of the most profound questions ever asked: are we truly alone in the universe? Perhaps, with continued exploration and the relentless curiosity of science, this question may finally find an answer, not in distant galaxies, but in the quiet orbit of a small planet around a faint, flickering star just beyond our doorstep.